Yeah, welcome everyone to Cloud Computing and Big Data today. Today's lecture 8, Infrastructure as a Service. And in all the slides, in a way, basically you have already experienced what infrastructure as a service is before even knowing it. So in a way, when we're using already Hard Insight with Apache Spark, we use some form of an infrastructure underneath. And in a way, this was provided by an infrastructure as a service model, but where other services are built on top. And we come to this today and describe it. Also, when we talked about EC2 and in the assignment, also when you think about the last lectures we had, so let's go a little bit into the last lectures before we try to have a bit more conceptual view of what infrastructure as a service really means, where it's useful, and how we can connect it, for instance, to methods or paradigms like MapReduce, for example. So before we go into the material of lecture 8, let us review what we had the last time. We had a very practical lecture, which was directly related to your assignment 2. We learned something about artificial neural networks and deep learning networks already in lecture 6 and lecture 7. And what really lecture 7.1 was doing, connecting all these different, let's say, more conceptual pieces and provide you some really, let's say, illustrative practical example on it. And we started a little bit with this MNIST because that's what you knew already from our practical lecture 01 before we even really started the course, so to speak. We did some data inspection, understanding the data, what really means gray value here in terms of numbers. We learned a little bit about the idea then that there needs to be different training and test sets. So once is a training set I use for my training, for my modeling of the model. And when this is done, then I use a test set to really check if the accuracy is what I expected. We have learned lots of details that I omit a little bit about this. You know, it was based on optimization, this training and so forth. And the really important part you see there is the red arrows basically here in this perceptron model, because this of course means also where really the training takes place, right? So we're changing weights. This is the kind of key idea in this neural network designs, even if it's a small perceptron like this. But basically, the small perceptron is exactly the building ground that we had also for the artificial neural network. We just connected them, if you remember, to have, let's say, different decision boundaries and not only one. We learned also in the practical example that before I stick something like this, a real practical character recognition problem, into such a neural network, we have to do, after some data exploration, also some normalization so that the values, not exploding when I do multiply by multiply or changing the weights, because then I can end up to either vanishing gradients or basically exploding gradients. We have some flattening to do, basically vectorizing, because we have a one-dimensional input to a neural network. And when you think about this, this was exactly the problem we had a little bit with this. By thinking about, you had this multi-output perception, okay, limited model, we know that I'm 91%, 20 epochs, if I train more, by 200 epochs, maybe then I get a bit more percentage, but really 95% would never be achievable with multi-output perceptrons. But what about a neural network with 2 hidden layers? So that should be something, and we learned, okay, if you do it in 20 epochs, it is around 95%. But then if you continue doing this, and we had the example with 200 epochs instead of 20, we maybe increase up to 96, 97, it's optimization, so it's never really accurate, basically to come to a concrete percentage that, will stand the test of time. So it's always around these values. But we have seen also their limits. No matter how long you train, even it's getting worse, it kind of problem we call overfitting, right? So that's basically what you see here on the bottom right, what was also described by Rocco already and Gabriel. If you train too long with a number of iterations, then suddenly, of course, your training accuracy goes up. Basically your training accuracy goes down, that's what I mean, but the test accuracy is going suddenly with the arrow up, and then you have a big problem that, with a large arrow, your accuracy drops. and then significantly. It looks good in training because there the accuracy is better, but in real life it's extremely worse. And this means overfitting. The different combat tools against it, regularization is one of it, and validation is another one. But those are two topics we cannot really put here in the course too deeply. For some of you that noticed, of course, in practical lecture 7.1, we had already a little bit of validation inside. But yeah, again, this is something for a more advanced course. Another takeaway message, which is really important when you have a job interview, which is often a question that people are asking, a deep network is nothing else than just more deeper neurons. And by now, you know, hopefully very well, this is not the case. They are neurons, yes, but in a very precise setup. You have seen on the right-hand side, right? Also what Gabriel and Rocco already started. We had an example with MNIST the same way. We have convolutional layers, we had sampling layers, where we did some, for instance, also max pooling to do dimensionality reduction, the strongest signals survive. And with this, we basically have a complete different setup. And all in all, we create something which we can see with feature extraction. Here also on the interesting, basically website that you can play around with in the deep learning course here in the deep learning lecture last time, where you really see basically the subsampling on the one hand, so this getting smaller, but then carving out specific features on the other, basically then when we come deeper and deeper in the network. So of course, we're not touching here in the practical lecture ResNet 50, what was described by Rocco, for instance, where really lots of layers are there. So of course, for our training here in the course, that would be exploding because we learned also GPU resources are expensive. That's why you see in one part of the assignment, you don't have any GPU, so you have to stick with a slow CPU. And while that was fine for fully connected neural networks that you see here in the middle, this was basically fine here, but what basically was a big problem you have seen it towards the end of the last lecture, convolutional neural networks, and then with CPUs, even in a small setup here for a 28 by 28 pixel problem is already an overkill, or basically you have to wait a long time. And of course, we see the percentage increases. You see 99.36, so it's worse to do that. Otherwise, we wouldn't do that, right? But we see clearly in almost all computer vision tasks, if you, let's say, have enough data, that deep learning is much better than everything else. And of course, here in context of image recognition, it's often convolutional neural networks or adaptations of those. Towards the end, then we would like to see, of course, a speed up. So think again when we can think about clouds, they can interconnect GPUs, things we also cannot really do in the assignment because it's quite costly resources. But think away that what Rocco told you, we can really significantly push down the training time the more GPUs we have. Then, of course, there are limits, and this is really the last point I want to mention before we go. We saw later in the Google Collaboratory another cloud we use together, and that you will use also in the next assignment that comes after the second. Then you basically see there's still 99%, no matter how hard I do. And the reason is usually these kind of fellows, there's always noise in the data or something which is completely unrecognizable even for us humans. So how in the world should basically this neural network learn it? And this was basically where we stopped. We learned a little bit about the AMI image and the instances that we create from this. So we have seen lots of benefits when doing this, because then we don't have to install all these different packages on our own. And I think this is a nice link saying that exactly now this was basically using infrastructure as a service already with pre-installed software packages, images, virtualization. There's no large, big topic in terms of Amazon SageMaker, which also does a lot of other things we will come to in another lecture. But basically it says it's almost bare metal with a little bit of operating system and a couple of packages. And of course, this is fully loaded. That means if you want to install all of this and all the versions, it's quite actually a real benefit of do so. To maintain this with all the OS updates, with all the updates of the packages could be quite cumbersome. Hence, here's already one of your benefits for infrastructure as a service that we used. And I think Rocco, Shadi, my PhD students here in the course, they can tell you a lot about using different clusters, always have to go back to think about, is it the right versions in my Python script, right? Or do I have to change the Python script again to this other cluster? Is it a different version of TensorFlow or Keras? The AP changed, problems with the file system. It's not always so easy if you do it your own. And one of the benefits of the clouds is usually it works quite streamlined, but of course you have to pay the price for it. And then if you really want to use GPUs with it, then of course it can get right costly. And finally, the TPU, Tensor Processor Unit, was a very specific one, which is available in the Google Collaboratory, or Google Colab as people call it. Then you basically see you have also here and there hardware, which is quite unique that you can actually access. But let us talk now a little bit about the stream of the course. As I already said in the emails, we basically have our midterm through. That is basically in terms of lectures correct, because we have much more practical parts you see in the first half, because we, as I told earlier, actually we're listening a lot to student feedback to put the assignments early, and with this we basically have lots of ground already covered from practical details. So, however, what we missed a bit was the conceptual ideas and also how really applications are created from this, like Angry Bird, for example, which comes in the next lecture. And then, you know, services like Amazon SageMaker or so, or customer relationship management, how they work with software as a service. Lots of aspects we didn't really cover yet. So that's why we have, let's say, a sequence now of some conceptual lectures while you, let's say, work on assignment 2 in parallel. And assignment 3 will be given out next week, Thursday. I will talk about this then, so that you also can start working on assignment 3, which is a little bit the Google Collaboratory, but also a short data mining that we will then, by next week, already start with this final practical lecture here around 11. Right, so let's go to lecture 8, which is now really understanding IAAS really in detail, infrastructure as a service, and the idea of this provisioning. I think many of these aspects are already here and there in practice, so I will link back to things we have already done in the course before. And with this, we basically have then the opportunity to link this nicely back to the material we had. I think one participant is here not mute, so I mute you. Sorry for that. The different cloud service levels that we have to review a little bit. So what does it mean? We also have to learn a little bit that the boundaries between them are not strict completely, right? So it's sometimes hard to say now, is MapReduce really a platform? Or is it just, let's say, a package I install under the IAAS? There are, of course, different views sometimes on people and administrators to what extent it is used. Is it then used as a platform for many different users, or is just one user using it as a package for doing something small? Then it's probably not really a platform. However, we will shed light on this a little bit and give some practical examples. And usually you will find this mostly as selling arguments. We will go a little bit to the Advania, to Vern Global, do those clothes here in Iceland, but also then, of course, think always about AWS, because they have a very strong service portfolio. And we want to look a little bit what's beyond computing there as well. Of course, we relate this always now to cost. You are yet very sensitive to this, because of course in the practical lectures or in your assignments you use AWS Educate, for instance. But with this lecture I want to give you a little bit the clue that it sounds so nice using virtualization, using a little bit of super images already pre-configured, everything is nice. Of course we have seen here and there's some small error maybe with launching, or I cannot get my resources right now. But yeah, well, in the end, it's still nice, instead of, putting that in my own little cellar, creating an own cluster on my own, having 2 people working on it as a startup, which costs all the money too. However, what I want to show a little bit is, of course, the devil is in the detail. We will see it particularly in the second part, when you think about cloud storage data transfers with APIs, cost, data movement cost. And of course, it's on a gigabyte level. So you would say it only costs in the long run, maybe, but still something to consider, right? That of course all of these end up adding costs, and because you're not using Amazon S3 in isolation, you maybe use it with an EC2, and the EC2 also use an elastic file system, or maybe the elastic block storage. So this is something where you use, let's say, a service landscape, as we call it, right? Different services, and then of course the costs can quickly grow. Another interesting pointer, just that there are, of course, lots of diverse applications possible on IAAS, even if you would say it's, let's say, very, let's say, bare, as people would call it. It's sometimes even bare metal, so to speak, and you have to do everything on your own. Still, we see with here and there examples what you can do with such an IAAS offering in some specifics, like OpenStack, creating your own cloud, or go the HPC way, for instance, with the Advania data centers here in Iceland using HPC Flow. And then we have another application example where, of course, there are some cloud providers which are not sticking, like Microsoft, Amazon, or Google, basically, and just prevent one offering. Why not having services in all of them, right? And then choose the best of the worlds. So you're kind of dealing with a meta cloud, so to speak, that is, using on top of other infrastructures and again services. For instance, just using EC2, but put their NetApp applications on top. So these are different ways how you could use this as well. And with this, we would fulfill a lot of promises. Not all of them. You see, sometimes I said lecture 8, 9, and 10 will cover this. Of course, these are more general things where we then also in the next lecture will go to PAAS much more, and then also to SAAS much more. So understanding now basically this IAAS, and we basically use that today without even knowing what that term maybe is, or you don't know it yet. All of them have in one way or another that you see here some relationship to it and need it, because a cloud without any infrastructure is either, as I discussed earlier, a meta cloud, so using maybe underneath different clouds like the public clouds to create their own private cloud maybe, but everybody in a way needs really infrastructure, right? And so basically this should be provided and should be existing. The question is rather, do you do it as a service? So is it something what other people can access or use to do their own offering? So when we think about this now, we have to think about 3 layers in a way. And as I said, the boundaries, like in this very beautiful picture here from if you're on the right-hand side here, you see the really boundaries are not completely strict. You would roughly put them in the categories here, but infrastructure is usually really virtualization, IT resources, bare metal, and all what comes around it with networking, storage, of course, and some computing. And the PAAS basically is already one level up where you would say there's really a platform that has lots of functionality in it. Of course, it's also in a way a virtual image, but there's already service software inside, which makes it much more than just a virtualized IT resource. So this is something where now the discussion and debates usually begin. What is MapReduce? Is it rather part of the virtual IT resource? Or is it already a virtual image, right? Which has already the software MapReduce inside. So you see there's some boundaries which are not fully clear, but usually it's that with PAAS, other people using this significantly the service, you would say MapReduce as a platform would mean 10 users using actually this differently, or you put it in some form of another application again. And we will talk about this in the next basically couple of lectures, where we even combine the services on these different levels and basically have then also software as a service, which is nothing else than or more or less a web browser with some ready to run application, and lots of things are happening in the back using different cloud sources, cloud resources, but you don't even notice this often. And it's basically different users that are on all of these levels, right? You would say SaaS is really something what a typical end user would be. Platform as a service is people that, would be perhaps some developers, would be people that, create and different solutions on top of certain platforms. And then infrastructure as a service is really the domain of administrators, where they, create virtual IT resources in a virtual network solution associated with correct storage over the network and so forth. Just to review that, of course, these IAAS levels, I call them star IAAS, right? And nowadays you will see even database as a service. You find a lot of names as a service. We will see HPC as a service in a couple of minutes. So take away the message, because I've seen that many times that people kind of mix that up. That has in a way nothing to do with private, public, and hybrid clouds, right? Of course, in a way, there could be a hybrid cloud, which is basically SaaS and PaaS combined. But the kind of terminology is to be separated between the IaaS levels and what is the nature of the public cloud, the private cloud, and the hybrid cloud. Then software as a service, again, a short review. Really, we go into this next week much more in detail. This is something, the domain where you just enter a browser like Google Docs, since you know Soho, one of the biggest CRM systems, or SharePoint, where you know lots of things, functionality is just there. There's a client interface, you access it, and there's lots of things maybe in underneath, but you really don't need to know, and you don't want to know. You just use the service, you get charged for it, so you actually also have several, let's say, requirements for it in terms of stability, of correctness, and so on. Then PaaS is on another level. That's something where we will explore that the Google Cloud offers lots of platform elements, billing services, things what you need to really create your own application or apps. I think apps is one of the biggest user of this these days, where you have Angry Birds as a good example, using and putting together different platform as a service elements to create their own SaaS, to create their own Angry Bird game. And we will go into this architecture when we talk a little bit more about PaaS. Takeaway, it is more like Lego bricks. They are really good Lego bricks, already service-oriented Lego bricks you put together to build your castle, your car, whatever it is you build. And then you have essentially the lowest level where, this is a playing ground for many players, not only Amazon, Verne Global, or Advania here. It's lots of players which are there. I pick those because of our location here in Iceland on the one hand, and on the other, that Amazon has really a very broad service portfolio to be also combined in later lectures to understand what IaaS really means. But essentially, again, think about it, about more bare metal virtualized resources. Maybe here, as I said, database as a service could be something you argument about, but these days, databases are also more or less considered as an infrastructure. And you see master worker here, the MapReduce, a little bit, a paradigm which is maybe sort of a platform, but still very much infrastructure oriented for different users. So a good example, as I said, is of course the Amazon Web Services. You get really rapid access. You have used that now with the AWS Educate package already. I hope those people that started the assignments. In this case, they have lots of ideas how to do business out of this, of course. And for you, if you basically have a startup or a company, that's of course a quite good flexibility. You don't have no upfront investment. You basically also need no experienced administrators or so that know how to set up MapReduce, Spark, or any of the other 100 Apache projects. So basically you just go there, you run your applications, and it works. And on top of this, you can maybe create your service that charged, for very nice photos, maybe from the Nordic lights, right? For those that sit in the nature for all night to make very good photos and videos about that. They maybe want to charge it as a photos, sharing somewhere in the cloud. And they want to just pick the things which are there, putting basically the infrastructure, the data on with all the photos. And, you give me some credit swipe. I use some platform service in combination with infrastructure as a service, just storage for my photos. So of course, this is then something where you can get to more and more services. You will see you kind of tempted to use more and more services, and they of course encourage you to use it, right, with different services, as we will soon see when we see about the storage landscape in the second part. And this was of course going better and better the last year. So you have to see, when Amazon started, it was essentially just EC2, Elastic Compute Cloud, with a little bit of storage. And then they grow, and now you have almost 200 services. It's amazing how that development was, because basically people have embraced on the cloud model. We're using it with apps. Of course, this was also development that was contributing to it. The app stores, Apple in the whole with the iPhone. So all of this contributed to the tremendous success of cloud computing. And of course, why it's successful? Because there's a return of investment. You know, almost everywhere where you are seriously doing cloud computing, you are confronted with a credit card you have to put right into the system because it's payments. In AWS Educate, we don't have to do that. But even in the free tier, you have to first put your credit card so that you basically in chance when the free tier time or quota is off, is basically over, you basically say, yeah, I just buy a couple. So that's how you get hooked, right? With this kind of free services, which is kind of a business idea, of course, to be honest, right? We have to also speak about that. And then we will see that, of course, more or less some cloud players now have started to really making a market out of migration. So to be, let's say, a honest broker on top of Amazon, on top of Microsoft, on top of Google, to be transparent from them. And still, you have to pay also for their service, right? And that's why it works so well. There's really an interesting understanding of how you pay for the resources provided. And we, throughout the lecture, will now look into this. Here's just a little bit of the evolution when you think about the service portfolio 2018. These services on the right-hand side here, that's about a time where people were talking a little bit about artificial intelligence already, but analytics and was much more prominent. And now you see, basically, since deep learning, machine learning is getting more and more in hype, and we more and more have machine learning really as a large portfolio here, what you see from Amazon SageMaker up to Poly and others. And of course, it works well with other, let's say, services which are there. You know, machine learning lives from data, so you need some storage. On the storage side, we have, you know, simple storage, an elastic block storage, an elastic file system. So you see the elastic, the idea of the cloud of being extendable and then also shrink again if not needed, is of course inherent in the ideas. And also what has much more come in the last years is this container business. It started already with Docker, but now we have Singularity, we have tools like Kubernetes. We will also look in basically towards the end of this course. What are these systems? Mesos is another one, which really deal with containerized applications, which are a little bit different than just virtualization. And we will make the point then in the container lecture. Now, looking back, a plethora of services, another perspective, they also have very interesting ideas how to use them. It's not just pick this service, pick that service. So have also solution-oriented systems. You see here building a website is something we cover in the second part, but also launching virtual machine we already have done in lecture 4. Machine learning we have to use with the AMI, basically with the AMI image, and launching with virtualized resources. And we will also use SageMaker now, basically in one of the next lectures. So in this sense, you have seen a lot already with this infrastructure as a service or higher even. The most prominent example is this one. So, and we have basically reviewed that many times. I will not go again into it, but of course, think away that infrastructure service is very low in the hierarchy of the software hardware stack. So it's usually very hardware oriented, very much to the system with virtualization, maybe just on the OS level or package level. So usually this is a domain also where people really have to know what an SSH key is. And that's why I also teach that here in the course. It's a very essential element of really thinking about when you go out to the market, and you are in the interest of working in the cloud area, chances are that you have to know in an interview what an SSH key is, right? And this is quite important. Then we have used, as another good example, something what was in a way on top of IAAS. So it's one application, so to speak. We use Elastic MapReduce, but inherent, of course, these were EC2 resources from Amazon. And of course, we used the charging of the services for the Elastic MapReduce service, but essentially underneath was also indirectly charging EC2 resources. And this was a perfect example where you would say maybe MapReduce is much more as a PAAS here, where it could be, let's say, entered up for many different users in one company. And we have seen that works. This was multi-user with Yarn, with a scheduler. So that is something where you would consider rather a PAAS analytics service out of it. We have launched a virtual server cloud instance. Nothing else is essentially now the IAAS. If you do it with an AMI instance or with a typical Linux, we have seen there are lots of options we can pick from. Maybe also just a Windows server, right? Does not need to have any relationship with, for instance, machine learning that we had. So in SUSE Linux and Ubuntu Linux, different operating systems with some pre-installed packages, which is quite nice. But here and there also with some interesting storage to it. But we will review the storage in the second part of the course. So when we think about the different payment models, this is of course something where we see mostly the credit card, but still also differently. It's pay as you go, pay per use, which is really the idea that even if you don't really use a resource, you're not charged, right? Which is quite nice. Of course, sometimes it depends on which service level you are, because when you have a running MapReduce, of course, this is running. The server is waiting for getting your MapReduce job, so of course you charge. But if you think about storage, you buying your big hard drive is, let's say, 3 terabytes, and you put it there, and then you use just 100 megabytes. You still have bought the one for 3 terabytes, right? And in a way you pay for it. And this, of course, is something you want to avoid in the cloud. So usually they have payment models which go with a pay-per-use model. And subscription is also possible to get some savings. There are different models, but usually there's quite an interesting way that almost every time is some money involved in this if you go to the practice outside. There might be free tier eligible elements like we have seen in our assignment or in the practical lecture 7.1. Again, of course, think about it. It was a very cheap resource. So when you had ended this up, then you have to pay the much better prices here down there with real lots of memory, maybe for Spark or so. So of course, this is a business model behind infrastructure as a service. The better the infrastructure, the more you have to pay. And of course, this can vary when you need it, right? Here's a payment model with the elastic capability, which shows you this cost sensitivity a little bit again, right? So when you have here a general purpose one, a CPU, where you basically just really pay what you use, and you can actually save sometimes or getting, the CPU credits when they are idle and reuse it, so to speak, as a credit score or something like this when you need it again. So it's different models where you also are not completely, let's say, left in the dark and say you have ordered it and if you don't use it. So this idle time is sometimes also different, incorporated in the payment model. And of course, this varies massively between the different types of resources, but also about the cloud vendors. They have all a different idea essentially around this. Then basically how this connects to big data here towards the end of the first lecture, really. Think about this video. It's a, let's say, interesting video because it catches up on a few, let's say, high-level views on it. But if you pick big data out of this, it's quite interesting to think about how this is related, how you are having, of course, problems to deal with that at home, but not problems anymore in the cloud to do that, because there it's scalable. Of course, that costs more, but we have also seen there are lots of trade-offs where even if it costs more, the question is, do you want to put your big data in-house here, that you have lots of terabytes as disks here, or you trust the cloud, which does also replication. This is a sensitive topic, data loss, right? This is something for think about, especially in big data. Let's assume there will be another earthquake in Iceland. Let's not hope so, but if that's happened, like in one of the last lectures, and your hard disk is seriously shaken, and then your terabytes have maybe a big problem. Usually we have very good hard disks today, so it's not that easy to crush a hard disk. But in theory, it could happen that, for instance, even a coffee goes over it and there's a problem with it. So you see that clouds has lots of benefits. It has redundancy. It's had often the storage replicated. And of course, if big data is lost, often that means for a company, big problem, right? If it's just your little small MP3 collection that you maybe can re-download, that's not the issue. But for many companies, the value relies on the data. Think about Decode Genetics. I was there this morning, so for a meeting. And of course, data is tremendously valuable for that company, right? And this is, of course, something which is of utmost importance when you think about losing that data. So we must everything do to protect it. And one way is, of course, to do it in a cloud, but you don't have to do it in a public cloud. You can do it in a private cloud, but still, considering replication schemes and things like that, perhaps, to really make sure the data gets not lost. Right, and of course the infrastructure is essential to this. You need to have the resources, you need to have the redundancy, the service level really to do that, and of course the experts that actually have to configure all of this to make it also, let's say, secure, a topic we don't really talk very much in this course. But this is all for the first part of the lecture, and we see us in 10 minutes.